first thing on the test says simplify. Write the final form with no fractions. Okay. Cotangent squared x times tan x times sin x. All right. Can I change everything to sine and cosine?
Yeah.
What is cotangent squared? Cosine squared x over sine squared x. What is tangent? Times sine x. What will cancel out?
The sine.
All of it?
Yeah.
Okay. What else?
Cosine.
So what is my answer?
Cosine.
Cosine of x.
And it feels like so long ago that we did these type of problems.
And I have a question for you.
Yeah.
Does this seem simple?
Yeah, but I feel like I'm gonna overthink it though, you know? Like, I'm gonna be like, oh, common denominator maybe? Oh. And try and get like sine, cosine, sine squared cosine, and then try and multiply all of it.
Are we going to be able to use our paint sheet on the test, or do we have to memorize?
I haven't decided.
Oh.
When you decide about it in class, or will it be surprised?
I got a question though, because I was absent for a day, and I don't really know the half tables. Maybe.
Why don't you? Are you telling me you haven't done your makeup stuff?
Oh no, I've done.
Oh,
the
what?
majority.
What?
I've done the majority of it. I just got a bunch of questions. You know.
You're not really helping your case.
I know.
I will tell you that I hate to say I'm going to let you use your pink sheets. And the reason I hate to say that, because that's right. And the first page, if you don't know the first page, you're going to be sunk. So you've got to know that first page. All right? I understand the double angle and the adding and all that you need them, but you've got to know that first page. Is that a fair thing to say?
Okay, on the first page, when did we replace the pi over 2 with the 90 degrees of x's and degrees? Like, when did we use that formula?
We really haven't, but you have to know when we draw the graph that 90 degrees is the same thing as pi over 2.
Oh.
You understand?
Yeah. I didn't ever remember doing
That's when we did it, is when we drew the graph. Now, I will tell you, if there's any single mark on your pink sheets, you don't use them.
I'm kidding.
I mean, did I say don't write on them?
Yes.
And Chandler's not here to hear it because she was the one that didn't want me to say because I said so. So now I have a good reason, don't I? Because you know what? You can write a lot of things on them that you can't use on the test. That's why they have to be clear. This says, use addition or subtraction formula to find the exact value. I even say, I'm going to tell you to use this. That's a 4. Can't read that. Can we use that? Is that all right? Does that add up? So I have sine of pi over 6 plus pi over 4. What's the formula? Sine of pi over 6
Cosine.
Cosine pi over 4 plus cosine pi over 6
Oh.
sine pi over 4. I was really lost at the beginning.
When it says on the test, use addition or subtraction, then you better find addition or subtraction on your pink sheet.
Yeah.
Right? So that's kind of a hint, isn't it?
Yes.
All right. What's the sine of pi over 6?
Radical 3 over 2. No.
I disagree.
That's not right. 1 over 2?
1 over 2.
1 over 2.
What's,
I don't know what I'm doing.
what's the cosine of pi over 4?
Radical 2 over 2.
Yeah, right.
What's the cosine of pi over 6?
That's radical 3 over 2.
And sine of pi over 4?
Radical 2 over 2.
So is this radical 2 over 4?
6 over 4. Then you get radical 2 plus radical 6 over 4.
Remember this?
Yes. So on the test, are you going to give us which things to use, like pi over 6 and pi over 4?
On some I do and some I don't. Because for instance, if I gave you 165 degrees, tell me two things that add up to 165 that you could use. How about 30 and 135?
I was just about to say that.
What else?
I'm trying to think about right now.
Does one of them have to be 45 degrees if the number's 165?
Yes.
So what's 45? What goes with it?
120.
120? How about that?
I was thinking. I had something messed up.
There's more than one. Okay. What if I ask you for this one? It says use sum or difference to solve.
Yeah.
So what is it? Sum or difference?
Difference.
Difference. Well, so what is the answer to this?
That's the sine of 120 degrees. You got to figure that out.
Okay. Do you all agree? Do you understand where I got sine of 120 degrees?
Yes.
So what's the sine of 120 degrees? What quadrant am I in?
2. It's a 60-degree angle.
60. So this is radical 3,
3.
2 and negative 1. So what's the
So radical 3
over 2? Well, look at your formula. What formula does sine cosine minus cosine sum? So sine of the first minus the second. That's how we got it. this time, I want you to find tangent of x plus y. All right? Sine of x is negative 15/17, and I'm at quadrant 3. Why? Because you needed more information?
Yeah. I was like, I don't know.
Cosine of y is 9/41, and it's in quadrant 4. I don't know what they're watching, but it's loud. Can I draw those triangles?
Yes.
All right, quadrant 3. This is x. This is negative 15. This is 17. What is that side?
Negative 8.
Okay. And y is over here. Cosine, this is 9. This is 41. What's my other side?
40.
Negative 40, okay. So isn't my formula tan x plus tan y over 1 minus tan x tan y? Okay. What's tan x?
15 over 8.
Plus over 1 minus 15/8 times negative 40 over 9, right?
Yes.
How do you find that value?
Put it
Put it in your calculator, just like that.
So these are really like large numbers, but it's
I have no idea.
negative 185 over 672.
that's what I got.
Everybody get that?
Yes.
We're good? Katie, did you get that? Why not?
I don't know. I got negative 37 over 120.
I know why. Because that one right there, that should be a minus if you have an negative. Just doesn't take much to mess it up. All right. Ready to move on?
Yep.
Your calculator is very picky about a minus sign or a negative sign.
What difference does it make?
Well, because when you have, if I tell you cosine of theta is 3/5, I'm sorry, negative 3/5, because I'm in quadrant 3. find the sine of 2 theta. Can I draw my triangle?
Yes.
This is theta. This is -3. This is 5. What is this? Okay. So what's the formula for sine of 2 theta? You all agree? So it is 2, what sine of x? Times cosine of x? Is this 24 over 25? Okay. Now let's do cosine 2 theta. It doesn't matter which one we use. Nope. Which one do you want to use?
Cosine squared minus sine squared.
Is that right with you all? Cosine squared minus sine squared? So is that 9/25 minus 16/25? Is that right?
Yes.
Which is what?
Negative 7/25.
Right? Now let's find tangent of 2 theta. What's tangent of 2 theta? Isn't it 2 tan theta? Which is what? 2 times what?
Negative 4/3.
No.
Sorry, not negative. Positive 4/3.
2 times 4/3 over 1 minus,
4/3.
which is
16.
16/9. Can you get an answer for that? Liz, this got easier once you figured that fraction thing out, didn't it?
Just one.
I don't think so. Is it? Did y'all get one?
Because 2 times 4 over 3 just simplifies in 4 over 3.
2 times 4 over 3 is 8/3.
Oh,
Yeah.
That's why. Okay. I was like, okay, yeah, that makes more sense.
So what do we get? Negative 24/7? Does that make sense to you?
Yeah.
That makes much more sense.
I was
All
a little
right.
confused.
Moving right along, let's find sine of theta over 2. Do you know that formula?
Are we using the same information as the cosine of theta equals? Like, are we still using that triangle?
Yes. Yes. Same information.
4/5. Oh, wait.
Wait, you're not sure, huh?
No. Plus or minus. Square root of 4.
It's 1 minus, what's the cosine?
Negative 3/5.
So 1 plus 3/5 over 2?
Yeah.
So you get 8/5 over 2.
Which is
4/2.
radical 4 over 5,
Oh, I see. Confused.
right? Is that right?
Yeah.
Which is what?
Radical 20 over 5.
I think it's,
Oh, wait.
2 radical
Oh,
5.
4.
okay, 2 radical 5 over 5.
Why? Can you not just leave it as radical 4/5?
Do we leave radicals in the denominator?
No, but if like the whole thing is radical.
But radical 4 comes out.
Should it be negative then?
I was going to ask, is it positive or negative? What quadrant did it start in? 3. So it started between 180 degrees and 270 degrees. So half of it is where?
90 and...
What?
The second one?
Second quadrant. Half, you agree?
Yes.
Okay.
Positive.
We knew up here,
Oh.
we were between 180 and 270.
Yeah.
So when I divide it by 2, I'm in quadrant 2, right? So what is the sign? Positive or negative? In quadrant 2. Positive. So this is my answer. Now let's do the cosine. What's the difference?
It's 1 plus cosine.
So it is, under the radical, 1 plus, or 1 minus, isn't it? 1 plus a negative 3/5 over 2. Right? Which is what?
It would be 5 minus 3.
Is it 2/5 over 2?
Yeah.
Which would make it
2 over 10, which make it
1/5, which is 1 over radical 10, isn't it? Because isn't it under a radical? Oh, wait, no.
wait.
Radical 5. Y'all told me that was a 5, didn't you? Now, didn't we determine we were in quadrant
2.
2?
So it's negative.
So it's negative.
How are we in quadrant 2?
Because it's a half angle.
Remember we said we were half angle?
Oh,
We were,
okay.
because the same rule applies here that it applied on the last
I
one.
thought you meant we were starting in quadrant 2.
No. Our answer is in quadrant 2. What about tangent of x or theta over 2? What are we using? What do you all want to use?
Shouldn't we just use the, can't you do the sine over cosine?
Do you trust yourself?
Yes.
Okay. I'm just asking. So tangent, if it's sine over cosine, is that 2 radical 5 over 5 over negative radical 5 over 5?
Yeah, so the 5's cancel,
Okay.
and you get 2 radical 5 over radical, or negative 2 radical 5 over radical 5.
Hang on. Do you all agree with that?
Yes.
What happens to my radical 5s?
It cancels, so
Negative 2? Okay. Guess what's left? Identities.
I don't know, I feel like identities can go either way for me. Either they're really easy, or it's like I sit and stare at it and it just doesn't make any sense.
I agree with that. All right. Here we go. 1 over 1 minus cosine of x plus 1 over 1 plus cosine of x equals 2 cosecant squared x.
It's a difference of squares, or no?
Is it conjugates? Which is the opposite of difference of squares. Don't I want a common denominator?
Oh, so you just multiply each side by whatever it is.
Common denominator. So this is 1 plus cosine of x, and this is 1 minus cosine of x. Is that right?
Yeah.
What's in my denominator?
Denominator is 1 minus cosine squared x.
Did you change it on the,
I'm multiplying.
or no, I mean, yeah,
Change it to what?
science.
Sine squared x?
Yeah.
So what's in my numerator?
2
2 over
sine squared x.
sine squared x. Right?
Where's the fourth one?
2 cosecant squared x equals 2 cosecant squared x. This was one of the harder ones in the very first group you did.
I remember this one.
And guess what?
Easier now.
It's easier now. Yeah. It's easier now. Ready for another one?
Yeah.
Trying to make these up as I go, so you got to be a little patient. Because you know all these, so it's really no big deal.
Isn't it 1 minus cosine squared x sine squared x?
Yep.
Yeah. Let's work the right side. One.
And I think 1 plus 2 x.
It's what? Cosecant squared? So do I have sine squared times cosecant squared? Incidentally, if you hadn't seen that and you'd have foiled it out and changed the sine and cosine, you would get the right answer. What's sine squared times cosecant squared?
That is 1 over sine squared x.
Is this sine squared times 1 over sine squared?
So you just cancel those.
Yeah.
1 equals 1?
Yep.
I'm telling you, these are what you did at the beginning when you all were telling me how hard they were.
So we'll spend like 30 minutes on these easily.
Okay. You got one more example?
Yes.
Yeah, the hardest one you can do. That will be on the test. Like, the type on the test. Not just fun.
That would be very cool.
I will tell you these are very close. Okay? 1 plus sine of 2x.
Okay.
What do you want to do?
I'm foiling out the,
Foil the left?
yeah.
Okay, foil it and tell me what you get.
So you're going to get sine squared x plus 2 sine x cosine x plus cosine squared x.
Do you all agree with her?
Yeah.
Yes.
You remember to foil and not just...
Oh, so you get, and then the sine squared x plus cosine squared x equals 1, and then the 2 sine
Okay,
x equals
always look for sine squared x plus cosine squared x. Do you see that that's 1? What is 2 sine cosine?
is, that's the sine squared x